अनम्यूट कर लीजिए.
Okay, good. Anyway, more, I hope more participants will come.
Yeah. Maybe 2-3 minutes.
Anyway, keep on coming. How is the weather there? Cloudy?
Yeah, it is raining.
Oh, raining. Oh.
Foggy and raining both.
Oh.
Yeah.
While you are going down traveling along this,
Sorry.
very dangerous, right, nowadays.
Yeah, it is in like in evening
rainy
we have
season.
heavy rainfall, so it was not.
Rainy season.
Yeah. Hello, Ranjit.
हेलो, प्रणाम सर. नमस्ते सर.
नमस्कार. आप आ गए, बहुत अच्छा. बहुत अच्छा लगा. गुड.
और मनीष नाजा जी कैसे हैं? नरेंद्र भाई
बस ठीक.
रंजीत जी नमस्कार.
नमस्कार. दुमका साहब
नमस्कार. अरे सर नमस्कार.
नमस्कार.
हेलो.
अरे रंजीत जी नमस्कार. नमस्कार.
ठीक है. हाँ
सर.
बढ़िया. गुड. बहुत अच्छी बात.
चलिए, आप तो वैसे मुलाकात हो नहीं रही, ऑनलाइन ही मुलाकात हो रही है.
मैं यही कहने वाला था. मैंने कि आके मिलो तो अलग बात, तो वो तो ये तो ऑनलाइन ही हो गया है अभी. अभी ये सिस्टम ही ऐसा हो गया है.
Sir, it is 3:05.
Okay.
So shall we start?
I think yeah.
Maybe people can keep joining.
Yeah.
Okay. So good afternoon, everyone. Good afternoon from ARIES, Aryabhatta Research Institute of Observational Sciences in Nainital, and continuing our celebration of Azadi Ka Amrit Mahotsav to commemorate this 75th year of India's independence, which will complete in August 2022. So we have this week-long public outreach program, and every day we have some theme following which we have been conducting public outreach activities. We already had our documentary screening, discussions on astronomy-related topics, then history and growth of astronomy at ARIES. Then we also had a seminar on Tuesday. So today is the 4th day of this week-long series, and today's theme is atmosphere. And the first program today is going to be a talk by Professor Shamlal from Physical Research Laboratory, Ahmedabad. He's a senior scientist who works in the area of atmospheric chemistry and dynamics. I welcome you, sir. And with me, I have my senior colleague, Dr. Manish Naja, and I request Dr. Naja to formally introduce Professor Shamlal.
Okay, good afternoon and thanks, Biren. So I must say, or we should agree that in today's words, the air pollution on climate change has become very serious issue to worry. So in that reference to, and also in continuation of our Azadi Ka Amrit Mahotsav series, today we have Professor Shyamlal who will be telling us more on this topic. Professor Shyamlal is the emeritus professor at PRL Ahmedabad, as mentioned by Biren, and I would say he is basically pioneer or maybe first ever. He has made the first ever observation of vertical profiling of aerosol, ozone, and the several trace gases using rocket and balloon, like imaging these measurement up to height of around you can say 60 to 70 kilometers, and that is in the 70s or 80s. So that is the one famous pioneer work by Professor Shyamlal. And also the if you see on the several trace gases, he was also maybe I will say the pioneer in making the first ever vertical profile of CFCs. Like CFCs, the gases which are very important for the or critical for destroying the ozone in the stratosphere, basically say the ozone layer. So that is also made by him for the first time, I'd say. And then because that was in 80s or the early 90s, that was the peak period for the research in stratospheric ozone research. And then later, considering the importance of tropospheric region or this air pollution issue, he switched over to this region and studying for the air pollution. And in that reference, like when you see the air pollution, ozone again comes for the first time, or in the I say in the basically starting point. And in that also he has led the several research group for making the first ever observation of ozone and the other trace gases using the surface instruments. So wide network of the instruments was set up in different part of India. So he was also leading that activity. So covering the troposphere and stratosphere activity. And he was the basically you see the author or the co-author of the first ever report of the ozone, the WMO report. He has the several paper, more than 150 papers, and he is also a member or the fellow of the all the three academy in India. So with this very brief introduction, I would request Professor Shyamlal to deliver his lecture on this topic or the hot topic in the today's world. Professor Shyamlal.
Thank you very much, and namaskar to everyone. First of all, I thank Professor Banerjee and Dr. Naja for inviting me for this wonderful celebration being held at ARIES. And it is my pleasure to give this talk. I tried to be very simple in this, but of course there are some additional information if one tries to begin. So this may leave some more, of course, always there is since research we do, so a lot of opportunities, a lot of scope for doing more and more, but I will try to do the simple one. So thank you again, and let me begin my talk by sharing the, I hope it is it being shared or can you see?
No, sir, you have to click on that screen share option.
Okay, share.
Okay.
Oh, sorry.
Yes, it's full screen.
So I tried to make this atmosphere of pollution our changing environment. What is the role of air pollution, because that's very important nowadays. As you are very familiar nowadays with searching for life, Earth is the only planet where, as we know, life exists. And that's a very unique place in the universe. You can see the how nicely the atmosphere looks from a distance. And then you see in the atmosphere, of course, there are various, we have given nomenclature. Lower part is known as troposphere, up to 15 or 18 kilometers, and stratosphere, mesosphere, thermosphere. These are based on temperature profiles and various physical and chemical characteristics of the atmosphere. So if I go to the topic as such, air pollution, of course, we have the natural atmosphere where nitrogen is around 78%, oxygen 21%, argon around 0.9%. But then there are many other gases, which I cannot list because so many. So I tried to write that water vapor is another very important gas, and always we are looking for water in the Mars, on Moon, and other planets, and oxygen, and all. But then there are like CO2, methane, nitrous oxide, ozone, oxides of nitrogen, volatile organic carbon, and chlorofluorocarbons, and many, many more. So there is no end to list here. But if you change the composition of the atmosphere by any either man-made or like natural, like volcano or some, then we call it pollution of the atmosphere. So any change from natural atmosphere, if you add these because of power, because of transport, because of burning of biofuel, anything will add, and it is a polluted atmosphere. The pollution level may be different at the different places. So that's what I will try to tell. And there are various types of gases. Not only gases, also particles like aerosols, dust particles, add to the pollution. And some are radiatively active gases like CO2. They absorb the radiation and change the temperature profile or radiative properties of the atmosphere. CO2 is the main in that. Next is methane, then nitrous oxide, ozone, aerosols also. Then there are a lot of chemically active gases. Ozone is formed from various pollutants, but hydrocarbons, organic, other volatile organic carbons, carbon monoxides and oxide of nitrogen, they're all chemically active. So they do a lot of chemical activities in the atmosphere and change the burden of atmospheric composition. And these emissions are because of we need, of course, we are a big population country, and economic and industrial rate is very high. So you need a lot of energy, food, water, transport, and so all these emit a lot of gases, and these emissions then add to the pollution existing. So you can see below that the vehicles, powerhouse, so all these add to the pollution. Of course, population growth is it continues, and that also adds to the pollution. And we have the mega cities like Bombay, Delhi, Bangalore, Chennai, Hyderabad, and people migrate to bigger cities because of facilities available there, because of medical facility, education facility, of jobs. So like Bangalore, Hyderabad, Pune, the growth rate is very high. So all these, then you need a lot of other infrastructure and all that. So population adds to the requirements, and requirement like energy. Now we have, of course, a lot of energy for electricity purpose, lighting. Then we need like air conditioning offices, houses. We need power for various industries, various things. So need of for more and more power is there. And you can see that the need in India for the power is much more. It's going to it shows that from 2015 to 2035, it will be changed by 129% of roughly. So, and maximum in India. So you need a lot of energy to run the industries, run the agriculture things and all that. And if you see earlier, of course, I have seen little part, but before that also there was vehicles were not there, very limited vehicles. I saw this, so I have written that. Earlier, only 2-3 types of vehicles, cars were there. Ambassador was very popular, Fiat and Standard. But then Maruti came in mid-80s, and they were giving that, okay, you make 40,000 units. So 40,000 that time was big sell. For two-wheelers, we have to wait for many years. So these were not available. Just you cannot go a market and just buy it. Now they are available. You plenty, so you can buy whatever you want. So number of these vehicles, 4-wheel, 2-wheel, 3-wheeler, and all that, they are increasing so much. And if you see that annual production of vehicles, of course, 2021 it has reduced. Otherwise, it was around 26 millions of vehicles per year production. Of course, two-wheelers are more in that, almost 78, 80% of the total. Cars were around still 31, you can say 31 lakhs of cars being manufactured. And here it is registered motor vehicles, so it keep on increasing. But still, the per 1,000 people, the number of vehicles in India is still less. So we have still to go, like Germany, the developed countries, they have much more vehicles per 1,000 person. We are yet to go. So this scale will, where it will go, that's the concern. Once you have these industries and vehicles and all that, there are emissions of, like, if you burn anything, high temperature, NO2 will come. Then if you burn coal, SO2 will come. Of course, CO2, CO and all other gases also. So this diagram shows how much from 1950, almost our 75 years of period, very small emissions, and now such a large emissions. So this is changing the atmosphere. And of course, ozone, the only protective layer in the atmosphere, which saves us from the ultraviolet radiation from the sun, is also being attacked. We know that in the stratosphere, ozone peak is there. It's very good because it absorbs UV radiation. But in the lower part, in the troposphere, also ozone is there, but very small. But that is even that small part is creating a lot of pollution effects. I will show that. And so upper region, good ozone, lower part, bad ozone, and is also a greenhouse gas. So different regions, ozone is molecularly same, but properties or how it is absorbing different radiation, that matters. So here it absorbs UV radiation, here it absorbs IR radiation. So its properties are different in different height range. You know that, of course, ozone is formed from naturally from molecular oxygen, but destroyed by solar radiation, by the various reactions, including the chlorine, bromine, chlorine, or OH, NOx, chlorine coming from chlorofluorocarbons, CFCs. That was a major concern. And as you know, this is a very old subject from 1980s. And so we know, but in the Antarctic, Arctic, ozone loss occurs big scale. And every year in the spring of that place, when the sunlight comes after the winter, spring season. So ozone, large scale ozone decreases there in these regions, particularly Antarctic region, South Pole. And this is a big region, not small, around 25 million square kilometer. That is the size of America, suppose. India is around 5, so 5 times of the size of India. Big scale, and many times total ozone in this region is depleted. So CFCs were, but they were identified and taken care that we will not produce these CFCs. But the lifetime is large. CFC 12, 150 years, CFC 11, 50 years. So even though we have stopped these, they are decreasing slowly. So even now also, after stopping in 80s, 87, first protocol was signed. So after that, we have totally stopped CFC 11, CFC 12, which were the main culprit of ozone depletion. They are already. But then we have newer ozone-friendly substitutes for that, because you need refrigerator, you need air conditioning, and that is filled with all these HCFCs nowadays. Then we talk of tropospheric ozone. The chemistry is little different than because the ozone formation, you need atomic oxygen. Atomic oxygen in the stratosphere comes from molecular oxygen dissociation, but that needs UV radiation from the sun. In the troposphere, UV radiation doesn't come. So there are other ways to get atomic oxygen, and that comes from NOx, HOx of these reactions. Don't go for these, but what I'm saying that you need atomic oxygen, and that comes from like NO2 plus H nu, very simple. With the visible light itself, it can give you atomic oxygen. So then but then there is a loss also. So depending upon the amount of NOx, hydrocarbon, there is a balance, whether there will be loss or there will be products around. Cleaner region, there is a loss. Polluted regions, there is a production, but that also changes. So depending upon the balance between hydrocarbon versus this, we had measurements of ozone started at PRL in 1950. Actually, PRL was established in 1947, and Professor Ramanathan came and he started making measurements. So we had these observations when we started again surface ozone in 1991, 93 period, or from that onwards. So you can see very clear change from 50s to 90s. Because more pollutants like NOx, hydrocarbon, more production of surface ozone. I'm talking of surface ozone. And this is annual change. So very clear diurnal annual change in the surface level ozone. Now, let me come to greenhouse gases, which are really very important in climate. Not so in environment because they don't affect the health or but through the environment, through the heating, through the temperature, also they affect. So you know that greenhouse effect, solar radiation can come here, but it cannot go the IR radiation cannot go out, and it is trapped by many gases known as greenhouse gases. So once they trap, the Earth's temperature becomes warmer. So in the cold countries, you can see that they put these plastic or glass sheets to make a greenhouse. This is actually greenhouse. And they can grow plants even though outside temperature is very, very low. Minus, but a lot of snow, you can see snow, but inside is green. Because then the light is coming inside, visible light coming, but the heat, IR radiation cannot go out. That is trapped by the plastic or the glass. Same thing happens in the Earth's atmosphere. The greenhouse gases like CO2, methane, nitrous oxide, and ozone in the lower part of the atmosphere, they trap that and we radiate little less. So we get the heating. And you see, you burn anything, CO2 will be there. But methane, of course, from hydrocarbons, it will come, or from like paddy fields, it will come. So any biomass degradation will also give you methane. So it is increasing, methane increasing, but methane has many other features. Sometimes it was not increasing so fast, sometimes it is increasing, depending upon the many emission sources and sinks. You know that carbon dioxide is the major greenhouse gas, and methane next, nitrous oxide the third. But the efficiency to trap greenhouse gas, IR radiation, is more. If we take like effect of carbon dioxide as one effect in the 100 years, then methane is 25 times effective, and this is nitrous oxide is more than that, 200 times or so. So, but the amount of nitrous oxide is very small. This is in ppb, 270 ppb, whereas carbon dioxide now 400 ppm, and nitrous oxide in parts per billion. This is parts per million, so 1,000 times more. So effect is, of course. So these measurements are very essential to check, even though we know in the global region they are, but how much they are changing in the Indian region. The ARIES Nainital has been making these measurements jointly with the NIES Japan, and this is a very good diagram showing you, showing you the trend and the annual variability at ARIES. So CO2, methane, carbon monoxide also, when the burning is incomplete, you get CO. When it is complete, you get CO2. So you also get nitric oxide, which is not in this diagram, but nitrous oxide comes from agriculture. So they're all increasing. You can see that CO2, 2 ppm per year, nitrous oxide, 1 ppb per year, sulfur hexafluoride, also greenhouse gas, but the amount is very small. It is in parts per trillion. So, but effective lifetime is much large of these. We also ISRO many agencies like ISRO, DST, MOES, CSIR. They have been supporting such studies all over India. And we have a program from ISRO GBP, and many locations we started making measurements of these trace gases, including ozone, oxides of nitrogen, CO, methane, many gases. And continuous measurements of these so-called greenhouse gases, CO2, methane, along with carbon monoxide, are also being made at many sites, PRL, ARIES, ISR Mohali, NRSC Hyderabad, IITM Pune, using a very sensitive very good instrument. And we started PRL in 2013. And many places, including Goa, they were doing the sample collection, and since a long time, all the year itself, and it is being done. What I want to show you, don't go in the details, but I want to show you that the base level, so much increase can occur if there are various sources. So in a city like Ahmedabad, when there is a lot of powerhouse industries and transport systems, CO2, methane, carbon monoxide also, all you can see all together increase, and very large. Not only 400 is only here, but you go, so actually even the scale is limited. So 400, 500. So these are the emissions, may not stay, but because the winds will blow it and redistribute in the region. But the sources are there. That only shows there are big sources in the cities because of all these anthropogenic activities. Because of all these greenhouse gases increase, the temperature has increased. And from this is a global mean, from 1880 to 2020, you can see that 0.2 plus 1.2 degrees, it has increased, roughly 1.3. So everywhere, this is global of many sites. The earth is warming. We also have in India, IMD is doing at many sites, and this is almost 113 years data in this. We have now more. And this is as per some average methane observed temperature trend over India during this period. And you can see that here also the temperature has 0.2 to at least in this 0.7. So 0.9 degree it has increased in this period, 1900. So, and there is a more research done already, and you can see the trends in temperature in this region. 0.05 degree centigrade per 10 years, earlier, total long time period. But if you take that part of recent part, it was higher. So as the activities increase, the temperature increase rate also increased. Then this is the statement of IMD that these last 20 years, there have been many warm years, and the temperature was very high. Particularly 2016, the temperature average was 0.83 degree more. Somewhere in Rajasthan, it was very high temperature that year, 2016. So like that, many heat waves and a lot of energy, like you would have heard recently in Canada and northwest of US, very high temperatures were observed. Europe also very high temperature, and then rainfall very high in Germany. And we also listened that cloud burst, of course, in the Himalayan region, but in the like Maharashtra and all that, also very heavy rain pouring in a short time. So let me come to air pollutants. If you model based on the emission available, you will see that the Indo-Gangetic plain is the most polluted region. This is carbon monoxide using a three-dimensional photochemical transport model, Mozart. And this is, so broadly, of course, China also polluted. But in India, this region is the most polluted region. Also, the population is also more. Industries are more. And you can see from the satellite NO2 data, this is satellite column OV data from this period, 2005, there were some hotspot big cities, powerhouses. But in 17 and later, you can see much more, and this has increased. So more and more emissions of like pollutants. NO2, here sulfur dioxide, it comes from the coal. Coal has sulfur, so once you burn, this is 2005, this region, then 16 it became big. So much more of SO2. So means everywhere pollution is increasing. Then the aerosols also we talk, aerosol dust particles, of course, naturally lifted or by vehicles lifted. Then other chemical aerosols like sulfate, nitrate, and all that they have. So the chemical properties of small aerosols, small size, PM 2.5, PM 10, then black carbon. So the size range of the aerosols from 0.01 micrometer to 20 micrometer, bigger particles settle down faster, but the smaller particles can go up in the atmosphere. And like this PM 2.5, when you inhale, it also goes, or PM 1 or even smaller, they go deeper in the lungs and create problem, maybe a lot asthma problem or other problems. So these aerosols also very important, like trace gases, because they also radiative forcing, direct, indirect, and climate perturbation. The sulfate aerosols cool the atmosphere, black carbon hits the atmosphere. Then chemistry, they have a lot of chemicals. So the surface area has a lot of chemical properties, and it can destroy ozone also. There are some of those, and also participate in the ozone destruction in the polar regions, stratospheric polar stratospheric clouds. Then environment degradation, so reduces visibility, problems in remote sensing, health problems. So aerosols equally important, and their levels are changing, of course, different places. You don't go to much of these, but I just want to say that Delhi, you see the scale, and this scale only you see Hyderabad, the other place, Calcutta. Delhi has very high level of PM 2.5. And so, of course, seasonal variation is there. Everything is low in the monsoon season because we get the very good air from the Indian Ocean, Bay of Bengal, Arabian Sea. So that air brings unpolluted, but then it mixes with the pollution. And so everywhere, every time for all these gases or particles, the monsoon season is cleanest. Then these measurements of black carbon being made at ARIES since a long time, and it has a lot of information. So I said black carbon is like a greenhouse effective gas or particles. So they heat the atmosphere, whereas the other sulfate aerosols cool the atmosphere. So they have the different properties. Then because of they go inside the lungs and create a lot of problems, there are a lot of studies doing that the mortality due to air pollution. Again, this is an estimate by Laliwell et al. And you can see that the Indo-Gangetic plain, these are very high, or cities wherever emissions are more, you can see these more of these health problems. And then there are many studies nowadays about the health and death linked to air pollution. And this is the Lancet study published in 2017. Updates are available. And it says that around 1.8 million people deaths are linked to air pollution in India. And so large number, but I am not very certain how they get these numbers, but if not 1.8 something, and but there is a serious problem. Then these pollutants like ozone also affect the agriculture. One case is for ozone, and high level of ozone can destroy various crops, rice, wheat, corn, soybean. And we have done one study. There are many other studies available using data from these ISRO GBP supported measurements places. We found that wheat with those levels of ozone and 4 to 14 million ton, or 4 to 15% of the total wheat is lost because of ozone pollution. Similarly, rice also, but rice is less. Wheat is more because wheat is grown in the northern region, particularly Indo-Gangetic plain where pollution is very high, and winter pollution is already very high. You have observed that because of the low boundary layer. So what the future says, much time I have, my time is already coming to the end. So the future being estimates for temperature change. I saw you earlier that already 1.2 or so the temperature we have seen the increase. If we continue now in the future, the emissions, but then we don't know how it will go. So there are some estimates that, okay, four such scenarios you take. Minimum controlled emissions and normal emissions. So with the minimum controlled emission also, you get temperature increase, of course, up to 1. We want to control below 2 change. This is too much. So it will be very difficult to survive in this. Of course, we are surviving, but very difficult. Nowadays, already we are seeing so many strong rainfall or heat waves or very, very natural activities being forced by air pollutants. So greenhouse gas, particularly in this case for the temperature. And so there are 4 scenarios. And in the 4th scenario, this is the temperature range. Same way, PM 2.5. They say that up to 2030-40, it will increase, even with the minimum controlled emissions. But then only, so it will take time. Next 10, 15 years more. But if you go for RCP 8.5, of course, it is a very strong case. So PM 2.5 will increase. That means health problem will also increase. Surface ozone. Many places it is going down because of they are taking a lot of control. But in South Asia, where development is more and control is not that much, it will except this one scenario, all the 3 scenarios are showing very high level of surface ozone. Many different countries, South Asian countries. So how the government is, what government is doing? We need a lot of power. It has to be there, more and more generation of power. So government is trying to generate more and more power because we need more power. But then coal, if you burn, it will give CO2 and other pollution. So you try to have energy from like solar non-CO2 sources. Coal is very bad in that sense. So we have to stick the amount of thermal power. So the government of India is trying to increase the use of renewable sources, solar in particular, and of course winds. And solar last few years, it's really tremendous increase. And there are many now solar parks. One is in Jodhpur coming up, and it's a very big 2,000 megawatt of power it will give. It is in 14,000 acres because desert and very good seeing, so sun, clouds are minimum. So you get a lot of good days to generate power. So India is trying to make use of solar power much more at a bigger step. That's one. Then Government of India's program, and also because of the availability of LED technology now, Government of India distributed a lot of bulbs in the beginning, free or at a subsidized rates. And that helped much. So as we know, we were using the normal bulb, then CFL came, and now LED came. LED are really very good. Illumination is same, but power consumption is much less. Also, lifetime of LED is much more. Even though it may be little costly, you can get in 100 rupees this bulb, but in 200-300 rupees LEDs. But the lifetime is so large and saving is so much that over a period of time, you gain a lot of money in that sense. So you save a lot of use of electricity, at the same time, long life of these bulbs. So this is really very the science and technology. Once LED bulbs are available, people have used now. So last many years we are using, and as it says, this last point, I cannot read this many times. The domestic LED market has grown significantly, and they are now selling in billions of these bulbs. So this Ujala program of Government of India really changed, and to the villages, to the streets, everywhere you see now LED light. I also have everywhere an LED light in my house, except one bulb, just for showing that this was the old bulb used. So this has really saved. And here there is some numbers are there. Reduction of 44 million tons of CO2 per year. Only these government, how much government has distributed, that has saved so much of CO2. So we have to save power, which in turn saves CO2 emission. Then Government of India also Ujjwal Yojana, and they have distributed 8 crore connections free, and also the cylinder at a very subsidized rates. So this is helping environment in the sense that it will reduce the burning of biofuels, and that means the pollution will reduce. Because otherwise, if you go to houses in the village, lot of smoke will be there because the poor people burn these biofuels, and lot of smoke and particles are there. So that emission of from the biofuel is being reduced. Also now, the LPG is almost being used by 95% of the population. So pre-distribution to poor people, and we were already using. So this has really helped in controlling environment. Vehicle regulations. Next, of course, we need vehicles, and the government has been trying to upgrade standard these for the emission controls. Various controls are there. One is the vehicle and even the fuel has high quality, and the vehicles are implementing that, and they need some change in the engines, and so the emissions are really reduced because of all these regulations. So for a if you take for a vehicle like in this BS6, nowadays BS6 is being used. Particles, oxides of nitrogen, and so they are much less compared to earlier BS4. BS4, now BS5 we have skipped. So directly have come to BS6. So this is another step which is controlling the emission of pollutants. Then agriculture burning, it happens in the Haryana, Punjab region, and after the crop is cut, they burn the leftovers to remove these things in a short time. But then the government of local governments and the central government are trying to convince them not to do this, and trying to give some help in that direction. And within a few years, this problem will also be solved. When you see that when the plume is coming from this region, very high levels of carbon monoxide, oxides of nitrogen, and ozone is formed from these. So ozone, all are affected by this. And Delhi, every time in November, there will be a lot of hue and cry in the Deepavali time, actually 15th of November, let's say, plus minus 2 weeks on both sides. High pollution events in that. When the air is coming directly from Punjab, Haryana, with the when these are being burned, you get very high level of pollution. So that will be solved, taken care very soon. So that also will help in controlling the pollution. And of course, we have seen that how in the lockdown period, when you stop everything, no vehicle flying except emergency people, and industries are not there except powerhouse and other things were there. But so much reduction in the aerosols or trace gases, you can was very clean atmosphere. Of course, difficult period. Lockdown period was very difficult because of all these things. And COVID, of course, has really created a lot of problems. A lot of people have died. So we try to control the pollution. And this is one example in that sense, that if you control these like vehicular emission, and then how much it can come down. So this is one. If you see from the satellite view, like NO2 and SO2, average for that period when there was a lockdown, March to April, 25 March to 25 April, 1 month. High level of NO2 normal period means or earlier years for that period only, but due to lockdown, much reduced. Same way here, SO2 also much reduced. So this not only surface level, but also in the column, these are controlled. So my additional suggestions, of course, this government is taking care of there are many steps government has taken to control the emissions. But I like to say more, and you all young people to take care of this. So needs to have cleaner and efficient technology. Like any engine you take, it should be more efficient and clean. So then the pollutants will be reduced already. Coal and diesel burning has to be limited because they emit large amount of this. Biomass burning, chulas, as I said already, government is trying to give LPG cylinders. So the chulas in places and crop remains burning have to be stopped, I think. And more use of CNG and LPG. Vehicular pollution to be reduced is already being, I think, not only those these BS controls, but now we are going to have battery operated vehicles. So all these emissions will be reduced much more. Already I can see few vehicles with a green number plate. Green number plate is given for these battery operated vehicles. So I see when I go out in the city, I see a few vehicles. Of course, not many because costly, but it will come in a few years. It will come. It actually it started, but then COVID has come, so that has delayed, but it will come. Then my suggestion, and I have seen many places, China universities, cycle stands are full. And our place, there is no cycle stand now, not needed means. Only four wheel vehicles or two-wheelers. So one has to use more of cycle. If you go to a nearby place, use cycle. So that will really help in traveling. So thank you very much. This is from IIT Kharagpur. And you see all these students, they use cycle. I want to see such cycle everywhere. And that I said that in China, not so much. Holland also, cycle so popular. So we have to use cycles. Then it will automatically help in reducing pollution, vehicular pollution. So thank you very much. And I can take some questions if there. Okay. Thanks for your interest.
Thank you, sir. Thank you for the wonderful talk. So let us check the questions. One question is on these stubble burning. Is there any alternative for that?
Alternative means you can cut and make these cardboards. Like in your region, Nainital side, when I come from Delhi, there are many places cardboards are being made. So these stubbles can be cut and used for that purpose or used for other purpose. Not just don't burn, but of course burning they have some plus point. I don't want to say that, but these can be used. A lot of pollution will be reduced. So that is one. Use in some other format. Maybe paper industry, maybe a cardboard industry.
Okay. I request participants that if they have any questions, they can use the raise hand option. Or you can also type your questions in the chat window.
Sir, may I have just a point of discussion with Professor Shyamlal sir. Sir, in continuation to the previous question, like somebody asked now regarding stubble burning. So my point is that since stubble burning or crop residual burning or say wood burning has been there for ages, if we consider cultural, ancient time. So I mean, then since mostly it will be emitting like CO2, CO, or mostly carbon. And forests are basically the major sink for the carbon, and they collect it through atmosphere, or say through soil. But then my point is that is that more alarming, or say harmful for the atmosphere, or say vegetation in all, or the kind of the technologies, or say the industrial development, or these I think the kind of chemicals are being emitted into the atmosphere, like we talk, say NOx and ozone and other. So I think and this should be the major focus, because these are more harmful. I mean, this is my point.
Yeah, that is correct. And actually, they don't have time, because they have to then grow the wheat, and the actually it is mostly for winter crop, which is
Right,
burnt,
right,
means
sir.
from the monsoon, the rice crop. So summertime we don't talk. When the wheat crop is burnt, nobody is talking
Right.
much. But some winter time, when the boundary layer height is low,
Right.
and the transport over IGP is always from the west.
Yes, sir. And that is well
Most of the
established. Yes, true, sir.
so, but that it goes up in the atmosphere, mixes for a larger volume. Only winter, when we
It
see
trapped
the,
in the very
yeah,
surface
exactly,
level.
and the
Yeah.
boundary layer has come down, and
Right, sir.
the wind is coming, and it is only for 15 November period only. December
Right.
nobody talks.
Yes.
So
True.
everybody will be talking, we will do this, we will do this. That is only in November.
Yeah.
But pollution is also there in December, in January. And always you see 400 to 250 to 400 microgram per meter cube of PM10 or PM2.5. So very high. Actually, these are high everywhere, because one, that we are in a dry region, and Thar desert is there, so dust comes. Then pollution, of course, is very high. If you go like in the Europe, your desk doesn't become dirty. Here you take, and then you will see the next day there is a dust everywhere. So already in India is a dusty environment, but the chemical pollution is another, and that comes from vehicles, industries, and forest halt period from this. So
Thank you,
instead
sir.
of burning, if they use for something else, it will be good.
Right. Thank you, sir. Thank you for such a nice talk.
Thanks.
Okay, Manish ji?
Yeah, I will just for the query, also discussion, and also for the information. Like I was just wondering, like we see you mentioned the energy demand of India is around 129% versus the global is only say 31%. And again, if you see the Brazil or China, they're also around 40, 47 something. So why in India it is the energy demand is so much? Whether it is maybe India is using old technology and now it is demanding high technology? Is that the reason? Or
That is, I do not know why, but that is estimate
yeah, yeah.
of.
So maybe
Sorry.
like like if you compare in 2015, so
Ah,
in India the worldwide or globe means like in different region they are using same some old technology when compared to Brazil or China.
I think our growth rate is very high,
Yeah,
industrial growth, very
and
high.
also like
China
related,
already, whatever they are.
yeah, they have achieved.
So we are in this slope,
Okay.
whereas others have almost, maybe China is almost there. I went, and the streets are so much flooded with light.
Yeah.
In China city, I went once. So I am not saying, but the requirement in India, what is projected,
Yeah.
is because we are in the growth, very strong growth period.
No, but again, in the same continuation, like then considering this much high demand, say this 129. So if we consider like in terms of the emission of gases, so like whether the which gas you feel will like CO2, CO or NO2 or particulate matter, so which we should very much, like it is combination of everything or uh,
Yeah. So anyway, that is all these actually we already have improvement, lot of improvement.
okay.
I can see in my city, Ahmedabad, when I came in 70s here,
Hmm.
the half eastern part of Ahmedabad had lot of chimneys.
Yeah.
Now those chimneys are not there.
Okay. Okay.
So already the technology is improving, but we are, like you said, the demand is so much.
Okay.
The vehicles, you see,
Right.
Yeah.
vehicles, but
Yeah.
still we need more because that to come up with the per family one vehicle and all that, it number will grow very large.
Yeah.
So, but then I hope electric vehicles will take over very soon.
Yeah.
So these are the things what government is trying to do. Government is trying to meet your demand as
Yeah.
well as control the pollution. I say that.
Okay, sir, next question is one young student has asked, what is the effect of greenhouse gases?
Effect of greenhouse gas is global warming. The gas, these gases, CO2, methane, nitrous oxide, sulfur hexafluoride, ozone, they trap the radiation. So if you trap more radiation, temperature increases. So that's where I have shown global temperature already 1.3 degree more than earlier, 1800 or so, not without industrial, before the industries began. And India also it has increased. So that is the temperature, and that increase in temperature is not that only heat. Then everything is changed. The whole meteorology is changed. The winds are changed, the monsoon is changed, and all that. So we are just last month only, America 55, 57-degree temperature. I was wondering how in such a high latitude region, Canada, west of Canada and west northwest of US, very high temperature and many for many days. So how that has come? Then Germany has very heavy floods. How that has
Yes,
come?
yes.
Because of temperature change, and that is because of greenhouse gas.
Okay, thank you, sir. Trupti Das, can you unmute yourself and ask your question?
Yes, Namaste, sir.
Namaskar.
Thank you very much for this presentation, very informative talk. Sir, I
Okay.
just had a question because these days there is a lot of discussion about switching over to battery mode, electrical mode vehicles. So, sir, I just wanted to have your personal views on that. So, do you feel that because is it really going to be a sustainable alternative to the fossil fuel?
Yeah, of course, when you say that, or when people say zero emission, it's not. Because you have to charge batteries. Charge batteries is why electricity only. And electricity generation causes a lot of pollution already. So it is not as such zero pollution vehicle, but a significant reduction. And in the cities, power is being generated at one place, and big chimneys and all the controls you have. Now, actually, like I said earlier, you don't see black smoke coming from the chimneys nowadays because they have variety of filters. Same way, the battery, once being the vehicle being operated by battery, there is no as such exhaust there. So no pollution coming out from the car. Is only battery which will be charged and the electricity and the electric powerhouse. So it will have significant difference. But where to throw those batteries? Battery life is 4 years. That's another question. So it will have its own problems until hydrogen vehicles come. In my sense, see, anything you burn with the carbon CH4 or C2S6 or any hydrocarbon with containing C will give you CO2. So remove C, burn hydrogen, then no CO2. So that is these electric, not battery operated vehicles will have their own problems, but significantly the local pollution will be reduced.
Right.
Thank you. Thank you, sir.
Okay.
Any other question? There is one comment. Why government is not making cycle compulsory in the university campuses? It will help change student mindset and they will accept it. Please suggest it to government. I understand. I mean, just doing so in university campuses won't help much. I mean, it has to be done even in cities and denser populated areas, dedicated cycle lanes and all.
Yeah. That is that's where problem comes. We have a road, and there is a separate for I think they said earlier cycle. But then the demand for the width is so much for the road. Vehicles are already long queues are there on that road. So they want to actually now remove that partition. And so the problem is to have a dedicated corridor for our cycles. Then if we can have, of course, that is the best. But it's very difficult. I cannot say in next few years, but it has to come. I always feel that cycle is the best, not only for pollution, but for physical activity also. So both ways. I want to buy a cycle, but the family will say, no, where you will ride? The car fellow will hit you. So that is the one danger.
Right. Okay, participants, any more questions?
Even afterwards, they can write to me at my Gmail ID, shyamprl@gmail.com. So if you are hesitant or if you have question later, you are most welcome to write anything, not only related to this or furthermore in this talk or anything else. If you want to ask related to atmospheric science, I will be happy to answer.
Okay, sir, since there are no more questions, I'll ask maybe one myself. So you were talking about these, how we have much lower number of vehicles per 1,000 people. And similarly, if we compare our largest cities, and they are comparable in population to some of the largest cities all over the world, say for example, Tokyo or New York or London. But if we see the top populated cities, they are mostly from India. And rather than the largest metros, it is many of the second tier cities where the population is lesser. Those are more polluted.
I went to Japan. Dr. Manish Raja has lived there for a long time. I had a very short visit, and I observed one that belly, the people are very slim there generally. So I asked my colleague, why people don't, I don't see fat people there. He said, no. You see, the transport system is mostly trains, local trains. From your house, you go to station. From your station, next station, you go to your office. And so in a day, 4 times you walk.
Right.
Walk. So that walking is compulsory there. And so it keeps your health also good. Not only reduces pollution. My colleague doesn't have a car there. Dr. Patra, he didn't have a car. Professor Kurjan didn't have a car because the transportation system there is so good. You don't need your car. Actually, having car is a problem where you will park and all that. So, but the government transport system is so much good from connecting Singapore from your house. You don't need actually buying vehicle in Singapore is not easy. It's very limited. So, if you have a very good system of transport, why you need to have your own vehicle? Parking will be a problem. Right. Nowadays, parking is becoming a problem, actually. That's why I said there that this last 2 years, last year was anyway COVID year. This year also, but lockdown is not there. The production of cars, vehicles is much less. We reached to 26 million, now 22 million. Because of BS6, because of parking problems. Parking, they are charging heavy fine if you park, they will take away your vehicle. And in the society, where you will put your car, park your car. So parking is becoming a problem. We need a good transport system for local travel, or for travel. So we don't need. That is another way to have limitation of this emission.
Right. Okay. No more questions. Okay, sir, there is one question on YouTube. Can forest be one of the effective sources to mitigate climate change, keeping in mind all the biological forces are destroying forests at such a fast pace?
Sources to mitigate climate change is control emission of greenhouse gases. And now how to control greenhouse gases? I have already listed a few. And there is no other way I see, because unless you control CO2, you cannot. So go for, actually it is coming, a lot of research is being done on hydrogen fuel cells. So once we get hydrogen fuel cells, no C in burning, no CH4, no CO, no any hydrocarbon, CH, only H, then CO2 problem will be solved.
Okay, sir. Thank you. There are no more questions. So I think we can stop here. Thank you once again for accepting our invitation for this talk at such a short notice and giving such a wonderful talk. Thank you, sir.
Thank you all for your time.
Okay, sir. Bye.
Okay. I think he can be there, remain, like we have
okay.
a session of the discussion.
Yes. Sure. So maybe we'll take just a couple of minutes break. Okay. And then we can start with the second session.
Maybe you can inform briefly about second session so the people who are online, they will know in the.
What is the next talk?
So the next talk is short discussions on various topics in atmospheric sciences by our research scholars. Okay. So we had selected like a monitoring of Earth atmosphere from ground. That is one topic. Then monitoring of Earth atmosphere from space. Okay. Good. Weather forecasting, achievements and challenges, and what can be done about climate change.
Very good. So after 10 minutes?
No, we'll just take maybe 2 minutes break just so that they set up in the meantime.
Maybe you can see the screen in the background that the students are getting ready.
Okay.
Okay, once you all are ready, just please unmute. Prajwal? Okay, just a couple of minutes. They are sorting out something.
Hello.
Yeah,
Oh, wait a second. There is some connection problem.
yeah.
Yeah, may I audible to all of you?
Yeah, you are audible.
Yeah. Okay. Okay, now.
Are we audible now?
Yeah, you are audible. Can you minimize this Zoom window from your screen, Prajwal?
Right?
Yeah.
Is it okay or?
Okay, what you can do, you can stop sharing and then you can just share this PowerPoint rather than sharing your entire screen. Start the presentation and then share the presentation mode.
Okay.
ये यहाँ से नहीं बोल रहे, यहाँ से नहीं बोल रहे.
Right? Yeah, or something.
Okay, fine. You can just slide it off out of the view so that it is not covering the. Yeah. Okay, fine. So who will be starting?
Yeah, both.
Okay. So Mahendra, तुम हिंदी में भी कवर करने वाले हो ना इसको?
Yeah, right.
Okay.
मैं हिंदी में लूंगा और प्रियंका दी इसको इंग्लिश में थोड़ा जैसे कम्युनिकेट हो।
ठीक है। So अब हम सेकंड सेशन स्टार्ट करने वाले हैं, which is a discussion on atmospheric topics. जैसा आपने कि अभी सुना महेंद्र को, महेंद्र हिंदी में बोलेंगे और प्रियंका इंग्लिश में इस टॉपिक के बारे में बात करेंगी।
Okay.
Hello everyone. So Virenjit, can we start?
Yeah, sure. Go ahead.
Okay. So thanks to the organizers and again our previous speaker, Professor Shamlal, who has already set the platform for us. So now we'll be discussing, so this session will be very basis. He has already covered the major scientific advancements related to both pollution and in air pollution in general, how it has been going. Now we are here to discuss the very basics. And just to set the pace, very quickly, we'll start with a explainer video. So here it goes.
Hello everyone, I'm Priyanka Srivastava and I work as a SRM at ARIES in ISRO RFI project under Dr. Manish Naja. Today I'll be briefly telling you about my work on carbon aerosols and trace gases. So what is BC or OC? Black carbon and organic carbon are the particulates emitted from incomplete combustion of carbon-based fuels from domestic burning or biomass burning, industries, vehicles, forest fires, along with trace gases like CO and CO2. But how do these carbon aerosols actually affect us? Let me explain. They actually affect our health, cause atmospheric warming or cooling. They even alter cloud formation and rainfall patterns and exaggerate snow melting. But still, its combined effect with OC and other trace gases remains unknown. AOD and greenhouse gases have also been shown to be on a continuous rise. And still, we do not know what contributes how much. Emission estimates have high spatial and temporal uncertainty. Indeed difficult, but we have worked around ways. Depending upon the relative proportions of species, we can differentiate between primary and secondary pollutants, fossil fuel and biomass burning, and assess the combustion efficiency. When the combustion is efficient, more CO2 is emitted, while when inefficient, more particulates or CO will be emitted. Although high up, it is expected that even Himalayas are prone to these emissions. So, at ARIES, we are trying to assess these emission sources using 4 set techniques, observations, and models. For more on our work, you can reach us via email or visit our poster. Hope you enjoyed watching this video created with these amazing folks. Thanks a lot for your attention. Have a good pollution-less day ahead.
तो जैसा कि आज का थीम है इस डिस्कशन ऑन द एयर पॉल्यूशन यानी कि वायु प्रदूषण और क्लाइमेट चेंज वातावरणीय चेंज के ऊपर। तो इसके थीम के अकॉर्डिंग हम लोगों ने अपना जो डिस्कशन है वो रखा है इन सिटू मेजरमेंट ऑफ एयर पॉल्यूटेंट, यानी कि किस तरीके से हम किसी जगह पर इन एयर पॉल्यूटेंट यानी कि वायु प्रदूषकों का मेजरमेंट करते हैं। तो सबसे पहले इसी श्रेणी में हमारे सबसे पहले जो शब्द हमारे मन में आता है वो है वातावरण या एटमॉस्फेयर। तो क्या एटमॉस्फेयर में कौन कौन सी गैसेस हैं, क्या उसका कंपोजिशन है, आइए जानते हैं।
Okay, So as Mahin said, the first question when it comes to air pollution is what is actually atmosphere made of? So atmosphere is a mixture of various gases with suspended, solid and liquid particulates, and they envelop the earth. Now you can see in this very image, the thin blue glow that you see, this is our atmosphere. And it composes of fixed and variable proportions of gases.
तो जैसे कि मुझे दिख रहा है यहाँ कि यहाँ पे दो तरीके की फिक्स्ड और वेरिएबल गैसेस हैं। तो फिक्स गैसेस वो गैसेस हैं जिनका जो कंपोजिशन है या जिनका जो अमाउंट है वो बहुत लंबे समय तक का पर्यावरण में बना रहता है। जैसे कि आप देख सकते हैं कि नाइट्रोजन का कुछ मिलियंस ऑफ ईयर तक यह हमारे वातावरण में बनी रहती है। वहीं दूसरी तरफ हमारे साथ वेरिएबल गैसेस है जिनका जो कंपोजिशन वातावरण में है वो जगह के साथ और समय के साथ परिवर्तित होते रहता है।
बिल्कुल। और उसके बाद जो अगला सवाल हमारे मन में आता है, इफ ओके दीज आर द पॉल्यूटेंट्स, आई मीन बट व्हाट आर द पॉल्यूटेंट्स इंडीड? आई मीन दीज आर द, not everything can be a pollutant, right? So what are the key atmospheric pollutants?
इन्हीं वेरिएबल गैसेस में से हम लोगों ने कैरेक्टराइज करे हैं दो अलग अलग तरीके के गैसेस ग्रुप्स को। एक है एयर पॉल्यूशन जो कि कम समय के लिए और कम समय के लिए और जगह से जगह बहुत जल्दी वेरी करते हैं। उसमें आते हैं कार्बन मोनोऑक्साइड, लेड, नाइट्रोजन डाइऑक्साइड, ट्रोपोस्फेरिक ओजोन, पीएम यानी कि पार्टिकुलेट मैटर 2.5 एंड 10 और SO2। और इसके साथ और सारी भी गैसें हैं जैसे नॉन मीथेन हाइड्रोकार्बन, ब्लैक कार्बन। वहीं दूसरी तरफ जो क्लाइमेट चेंज के बारे में हम बात करते हैं,
तो बेसिकली एयर pollutants means they will actually affect your health and they will also contribute to environmental degradation. But on the other hand, the greenhouse gases are mainly responsible for capturing the IR radiation and in turn enhance the temperature of the atmosphere.
तो एक जो इमेज के माध्यम से हम ये दिखाना चाहते हैं कि किस तरीके से जब हमारे वातावरण में प्रदूषकों या एयर पॉल्यूटेंट्स का अमाउंट बढ़ जाता है तो जो हमारा विजन होता है, विजिबिलिटी होती है, वो किस तरीके से गिर जाती है और हम किसी भी चीज को, जैसे इंटरगेट के पिक्चर को हम देख रहे हैं, किस तरीके से परिवर्तित हो जाता है। वहीं दूसरी तरफ ग्लोबल वार्मिंग या जब हम टेम्परेचर चेंज, क्लाइमेट के बारे में बात करते हैं तो हम लोग करीबन 20 से 100 सालों के बीच का टेम्परेचर चेंज को कंसीडर करते हैं। तो हम ये देख सकते हैं कि हमने ग्लोबल टेम्परेचर रिकॉर्ड से ये डेटा लिया है और 1860 से अगर हम देखें तो टेम्परेचर पृथ्वी पर जो है धीरे धीरे बढ़ता जा रहा है। तो
Okay, again this brings us to the next question, which is okay, आपने ये measure किया, but आपने ये measure कैसे किया? So how do we measure or observe them?
तो इस चीजों के लिए जो हमारे जो मेजर करने की या ऑब्जर्व करने की, कि इन प्रदूषकों को या ट्रेस गैसेस को मेजर करने के लिए हम लोगों ने अलग अलग तरीके की सिस्टम्स क्रिएट किए हैं या टेक्निक्स क्रिएट किए हैं। उसमें सबसे पहले जो हम लोग बात करेंगे वो ट्रेस गैसेस मेजरमेंट के लिए है। ट्रेस गैसेस मेजरमेंट के लिए हम लोग ट्रोपोस्फेरिक ओजोन, नाइट्रोजन डाइऑक्साइड, नाइट्रिक ऑक्साइड, कार्बन मोनोऑक्साइड और बहुत सारी गैसेस के लिए गैस क्रोमेटोग्राफ, थर्मल इंस्ट्रूमेंट्स, वहीं अगर वर्टिकल प्रोफाइलिंग जैसे श्यामलाल सर ने पहले भी बताया है कि अगर थर्मल स्ट्रक्चर देखना है तो रेडियो सोंडे का भी हम लोग यूज करते हैं। वहीं दूसरी तरफ एरोसोल मेजरमेंट के लिए
जिस तरीके से हमने ट्रेस गैस मेजरमेंट्स करी और उसमें हमने एब्जॉर्प्शन या थर्मल टेक्निक्स को इनकॉर्पोरेट किया, बिल्कुल उसी तरीके से हम एरोसोल मेजरमेंट्स में भी ऑप्टिकल टेक्निक्स और थर्मल टेक्निक्स दोनों को कंबाइन करते हैं और एथलोमीटर या पार्टिकल काउंटर्स या नेफ्लोमीटर जैसे इंस्ट्रूमेंट्स के जरिए या सन फोटोमीटर के जरिए हम एरोसोल मेजरमेंट्स को करते हैं।
और वही जो टेक्निक्स हैं ये केवल एक ही स्थान पर सीमित नहीं रहती, बल्कि हम इसको शिप बॉर्न यानी कि जो हमारे इंस्ट्रूमेंट हैं इसको अपने शिप में रखकर वो पूरे समुद्र के भी गणना कर सकते हैं। वहीं दूसरी तरफ जैसे पोलार रीजन्स या कुछ रिमोट रीजन्स में भी जाकर, जैसे आप प्रदर्शित कर देख सकते हैं कि यहाँ पर एक AWS लगा हुआ है और साथ में 2 ऑब्जर्वर भी मौजूद हैं। वहीं एयरक्राफ्ट मेजरमेंट भी किया जाता है। तो डिफरेंट तरीके से, और ये एरीज में होने वाले हमारे बैलून एक्सपेरिमेंट का फोटो है जिससे हम लोग वर्टिकल ओजोन का वर्टिकल टेम्परेचर और कुछ मेट्रोलॉजी पैरामीटर का प्रोफाइलिंग करते हैं।
बिल्कुल उसी तरीके से हम लिडार और रेडार्स जैसे इंस्ट्रूमेंट्स को भी इस्तेमाल करते हैं ताकि हम वर्टिकल स्ट्रक्चर को जान सकें।
तो फिर हमारा जो मन में प्रश्न ये आता है कि क्या यह जो ऑब्जर्वेशन है क्या एक हमारे ही इंडिया या कहीं सीमित है या कहीं और भी इसका नेटवर्क है? तो
या बिल्कुल सिर्फ इंडिया, मतलब क्या ये केवल एरीज तक ही सीमित है या हम और जगह भी इनका मेजरमेंट देखते हैं? तो डू वी हैव द नेटवर्क ऑफ सच मेजरमेंट? सो यस इंडीड, जब भी हम ग्राउंड ऑब्जर्वेशन की बात करते हैं तो वो एक जगह से नहीं हो सकती एंड वी डू नीड अ नेटवर्क ऑफ ऑब्जर्वेशन। जैसे कि सिमिलरली हमारे पास एयर क्वालिटी इंडेक्स के अंदर आने वाले 8 पॉल्यूटेंट्स को मापने के लिए CPCB यानी कि सेंट्रल पोल्यूशन कंट्रोल बोर्ड के द्वारा जारी किया गया एक नेटवर्क है। उसके बाद इसरो आरफी जिसके अंतर्गत हम लोग ब्लैक कार्बन जैसे इंपॉर्टेंट एरोजोल्स का रेडिएटिव फोर्सिंग में कितना कंट्रीब्यूशन है ये ज्ञात करते हैं। इसके बाद डॉपलर वेदर रेडार्स का भी हमारे देश में एक नेटवर्क है जिसके जरिए हम आने वाले साइक्लोन्स के और रेनफॉल पैटर्न, रेनफॉल में किस तरीके का मॉइस्चर है हमारे एटमॉस्फेयर में ये जान सकते हैं।
तो ये तो बात हो गई कि किस तरीके से हम इन पॉल्यूटेंट्स या इन मेट्रोलॉजिक पैरामीटर का ऑब्जर्वेशन करते हैं। क्यों तो अब बात करते हैं कि क्या एडवांटेज हैं या क्या एप्लीकेशंस हैं इनके ऑब्जर्वेशन करने से। तो
ओके, सो व्हाट आर द बेसिक एप्लीकेशंस? नाउ जब भी हम ये बात करते हैं कि एटमॉस्फेरिक ऑब्जर्वेशन, सो दीज आर नॉट जस्ट डेटा, दीज डेटा एक्चुअली ड्राइव द डिसीजंस। तो ये जितने भी हमारे ग्राउंड बेस्ड नेटवर्क्स हैं अक्रॉस द वर्ल्ड, दे आर हेल्पिंग अस टू सॉल्व द बिग प्रॉब्लम्स राइट हियर ऑन अर्थ एंड दे हेल्प द गवर्नमेंट्स टू फॉर्म इन्फॉर्म्ड डिसीजंस। आपने देखा होगा एक बहुत ही वेरी सीवियर साइक्लोन जो कि रिसेंटली आया था टॉप पे, उसका पूर्वानुमान लगाना एक बहुत ही इम्पोर्टेंट स्टेप था। हम बहुत लोगों को बचा पाए इसके लिए। तो ग्राउंड ऑब्जर्वेशंस जो है वो एज एन इनपुट जाते हैं सैटेलाइट और सैटेलाइट मेजरमेंट्स के साथ हमारे मॉडल्स में, और उसके जरिए हम फोरकास्टिंग करते हैं।
तो अगर हम हेल्थ और एयर क्वालिटी की बात करें तो हम सभी को हम जानते हैं कि हर जगह के लिए एक इंडेक्स बनाया गया है एजेंसीज ने, वो है AQI, दैट इज कि एयर क्वालिटी इंडेक्स। इसके अंदर बहुत सारे प्रदूषकों का माप होता है और उसके हिसाब से हम लोग इसको श्रृंखला वाइज विभाजित करते हैं कि कौन सी जो सिटी है वो पॉल्यूटेड है या नहीं है। तो उसी के लिए हम लोग कुछ ऐप वगैरह आजकल इस तरीके की ऐप डेवलप कर दी गई है कि आप अपने फोन में भी हैंडी ऐप्स हैं जो आप अपने फोन में भी उसमें किसी भी लोकेशन या किसी भी जगह की एयर क्वालिटी को मेजर कर सकते हैं।
और एक्चुअली आप डिसाइड कर सकते हैं कि आप अगर बहुत ही सेंसिटिव लोग हैं या आपको कोई रेस्पिरेटरी डिजीज है तो आपको उस जगह जाना चाहिए या नहीं, या उस समय में जाना चाहिए या नहीं। सिमिलरली एग्रीकल्चर में, जैसे कि अभी श्यामलाल सर ने बताया कि किस तरीके से ओजोन या बाकी प्रदूषकों का एग्रीकल्चर पे इम्पैक्ट होता है, एंड ऑब्वियसली कि अगर आपका मानसून समय पे आ रहा है या नहीं आ रहा है उसका एग्रीकल्चर पे एक बहुत बड़ा प्रभाव पड़ता है। तो यह सब ज्ञान जो है, ये सब डेटा जो है, ये इस ज्ञानवर्धन में ही नहीं काम आता केवल, बल्कि एक इसका प्रॉपर एप्लीकेशन है एग्रीकल्चरल सेक्टर में।
और इकोलॉजिकल फोरकास्टिंग में भी जिस तरीके से हम देख रहे हैं कि इकोलॉजिकली इन जैसे जैसे हमारा टेम्परेचर या दूसरी कारणों से पृथ्वी का तापमान बढ़ते रह रहा है, हमारी इकोलॉजी बल्कि सीमित होती जा रही है, सिकुड़ती जा रही है। तो उसके लिए फोरकास्टिंग में जरूरी है कि किस जगह पे टेम्परेचर कितना बढ़ेगा, हमें किस तरीके से वहां पर इकोलॉजी को डेवलप करना है,
किस तरीके का वेजिटेशन है और वो किस तरीके से बदल रहा है।
तो क्या हम इतने तक ही सीमित हैं या इससे आगे भी हम लोग मेजरमेंट या ऑब्जर्वेशंस?
बिल्कुल। सो द नेक्स्ट थिंग इज व्हाट नेक्स्ट।
तो हमें क्वेश्चन छोड़ते हैं
और हम ये बोलना चाहेंगे कि इट्स नॉट ओनली द इन सीटू मेजरमेंट्स बट देयर आर अदर थिंग्स व्हिच आवर colleagues will like to answer. Okay, so now I like to invite Prajwal who will
So,
hello Prajwal.
Hello. So, can I start now?
Yeah, sure.
Okay. So, good evening all. So, my topic is monitoring of Earth atmosphere from space. Why we need the space-borne observations for our atmosphere. So, and I will discuss some outcome of these space-borne applications. So, as we know that our atmosphere is an envelope of air. It is surrounding our Earth, and it is having different layers. Here you can see we have the different layers, and different kind of phenomena are happening here. Like somewhere the cloud are there, then flight are there, then whatever balloon we launch, they are reaching up to the stratosphere, then ozone layer is there, and at certain altitude there are satellites, space shuttles. So this is our typical atmosphere. So if you say that why do we need to study our atmosphere, or why do we need extensive observation for our atmosphere? So we know that different activities like human activities or the natural activities are producing various hazardous and undesirable solid air gaseous particle to our atmosphere, which is leading towards the inhabitable Earth. So if you see over the global map, what are the deaths due to pollution exposure, you can see that in the South Asia or in the India, the rate is very high. And in the next, if you see the population map, you can see that in the northern hemisphere, there is larger population density. So most of the population residing in the northern hemisphere. And if you see ground-based observations, they are also populated in the northern hemisphere. So we are not having a complete picture for any pollutant or any gases in our atmosphere. So to get a whole picture, like if you want to observe the globe as a whole, we need satellite observations. Also, we know that if a gas is emitting from certain source, it is taking about 2 weeks to circle the whole globe. So it is being transported from one place to other place. So to track these kind of things, we need space-bound observations. So in the space-based observations, we are doing the remote sensing actually. It is gathering information from a remote location in form of electromagnetic radiation. So we are having two kind of orbits. One is polar orbits and one is geostationary orbit. In the polar orbits, we can see we have a global observation per day. And in the geostationary, it is always looking at a certain part of the globe. It's in the geostationary orbit, the rotation period of the satellite is similar to that of the Earth. So it is always having eye on a certain place. So for different countries, they are having different kind of their geostationary satellite. So how do we get the value what we want to get from the satellite? So the satellite is recording a electromagnetic radiation. To get the information about Earth's surface or the gases composition, we use standard mathematical equations. Like we know that the Beer-Lambert equations is there, the radiative transfer equation, we know that. We utilize this kind of information to get the whole picture of our atmosphere, not only at the surface, but at the certain altitude of, at the certain height also at the of the atmosphere. So this is the scanning, typical scanning of the satellite. You can say this is the swath. The path of the satellite is known as the satellite swath. So here you can see different countries are launching different kind of satellites. So here you can see geostationary satellite are there, the near polar orbits are there, and also the Lagrangian point. So here you can see the India having the Kalpana and the INSAT 3D and 3D are right now in the operational mode. So they are looking at the Indian territory per hourly and giving us the data. So as I already told that with the help of satellite, we can get a global picture. So here you can say some gases, they are from the satellite observations. And here you can see that we are even able to measure them over the ocean regions. You can see over the pole, we can get the ozone hole very clearly. So this kind of pictures or the wholeness in our data can be obtained by the satellite utilization. So India is launching various satellites since the launch of Aryabhatta in the 1970s. Among the many focuses of these satellite instruments, one is Earth remote sensing for climate and environmental studies. And some of these are the Kalpana, INSAT 3A, Megatropics, and INSAT 3D and 3DR. So if you see the INSAT 3DR, which is the most advanced and operational satellite for India, you can see it is launched in 2016, and it is having 6 channels in the visible band and 19 channels in the infrared band. And it is giving us the cloud information, sea surface temperature information, vertical profile of temperature, humidity, and total ozone observations. So here I want to tell you, or I want to represent that how the satellite is used during the COVID-19 lockdown to track air pollution, which has been reduced. As we know that a lot of activities have been dumped or they are being stopped. So during this time, various emissions, like we were having no vehicles in the road, so that has dumped our NO2. So this is a typical image from Topomi satellite observation. So here you can see that this is for Paris 2019 and 2020, and this one New Delhi. So you can clearly see that during the lockdown, there is a drastic change or drastic improvement in our air quality, or the pollution have been dropped drastically. So this kind of information we can get very easily with the satellite observations. So I will thanks here, and I will also acknowledge some of the sites where I have got this information. So now, continuing this series, how the data is being utilized in the forecasting. So Mr. Jaideep will be telling about it. So Mr. Jaideep.
So hello everyone, I'm Jaideep and I will talk about the weather forecast and achievement and challenges. So weather forecast is just to predict the state of atmosphere at any space and time. So there are various kind of weathers we want to forecast, like extreme cloud event, like which basically drive the extreme event like cloudburst, the snow events, which is basically very important for tourism, the thunder and lightning. I will discuss it in later, that how many casualties are basically happen due to the lightning events in India. Similarly, the frost and ice, rain event, as we all know that recently a extreme event happened and which contribute to the landslide in Himachal Pradesh. The fog event, which basically drive the near surface smog, the air quality, as explained by previous speaker, which is very, very important for health hazards and etc. The hail conditions, which damages a lots of crop and agriculture sectors. Similarly, cyclones, which contribute to the socioeconomic losses, life losses. The temperature event, temperature basically we drive the, which regulate basically the cycle of summer monsoon and tornadoes, which is not in context of South Asia, and similarly the extreme weather like storm conditions. So these are some challenges that with the changing climate, which basically changing with the climate, there are many issues that are highlighted by WMO and different institutions over the globe. So in particularly focusing on the South Asia, more than 41 million people are affected by the floods. And similarly, it's affect the agriculture sector, extreme heat wave by drought conditions, as it affect the wildfire conditions. Like Uttarakhand is one of the major area where many wildfire events have take place. Similarly, the heavy rains we experience in all over from north to south over the Indian subcontinent. And the previous many extreme events are, well known to us. So some of the data from UN disaster management, it shows that during 2020, almost 15, which are reported basically, these are the 1400 lives basically we lost. And we can see this cartoon diagram. It's highlight that how these different kind of extreme events like cyclones, thunderstorms, extreme rainfall, and the lightning events are responsible for these deaths. These are not only the figure basically, not the total figure basically. There can be some of the deaths, those are not reported. Irrespective of the things that India is at third position of the socio-economic losses. And the report highlight that during the last 2 decades, or we can say that 20 years from 2000 to 2020, it is almost of the $3 trillion of the economic losses, which is about our, which is very, very comparable to our current GDP. So how many types of forecast are basically there? So according to, if we classify it by the range, means time range, there are 3 kind of: short range, medium range, and long range forecast. So the short range forecast is of 1 to 3 days, and the medium range forecast is 3 to 10 days. That range can vary slightly, it can vary. And the long range forecast is basically which is greater than 30 days. And that long range forecast also include that seasonal forecast, right? So what is the challenge basically? Why these are the different, the range of forecast? What is basically the challenge that how we cannot make a longer range forecast? So it is basically the quality of that forecast. So you can see on the right panel, this figure show that if that the error or the accuracy of the forecast decrease with the increasing the time of that forecast, right? So if the time is increasing, if this is decreasing, basically the forecast skill is basically highly dropped. So it happens by many reasons. You can see in this figure, this is a typical diagram which highlights how the model is basically work and why these the difficulty or the errors in the forecast are basically. So you can see in the first figure, first step of the accurate forecast, basically to making a setup of the forecast model, is to collect the static geographic data like vegetations, the digital elevation map, the surface albedo, soils characteristic, and etc. The second step is basically the collection of meteorological data, as explained by previous speakers, that which work as an initial condition for the model. And the third step is basically the model learn, which basically assimilate all those data from the space-borne, ship-borne, balloon-borne, and ground-based and satellite, etc. Assimilated, and that model it initialized with these initial conditions. So the output of this model is again interpreted by some subjective interpretation is carried out by meteorologist, which is basically a board member or etc. the panel members, and then outcome of this the impact-based assessment and other things, which is basically valuable for the government bodies, private sector stakeholders, agriculture sector, and etc. or defense and etc. Those are some users for this the output of this that product. So the model uses the data to initialize the calculation. Then model that data can have a lots of uncertainty, right? That ground-based, there are different limitations of ground-based, space-based, and radio sound observation having lots a range of errors, and which is basically initializing some model. So if there is any error in initializing data, definitely there will be slightly errors, or it will regenerate that error, and possibly it will rebuild that error to the used quantity. So similarly, the high resolution model calculation is another challenge which require huge computation cost. So you can see somehow if you are in mountain or somewhere very complex terrain, you will find out that your location, whatever the Google is showing you, the forecast is basically far from your location. So it is happening because that model is, the high resolution data is not available over that region. The ability of the model due to the maximum physical process is also a challenge. For example, there are some physical processes which are only over the subtropical region, but we are running that model for the tropical region, and some physical processes which are basically driving the mechanism over the tropical region, but they are not in our model. So there should be maximum physical processes and accuracy of those all physical processes parameters and should be in our model. So one of the major challenges is tuning of the forecast model. There are various constant and parameters in the model. Those are basically spatiotemporal dependency. So accurate estimation of those all constants should be highlighted and investigated. So in case of I will highlight the achievements of our region, the Indian subcontinent. Then the Indian Meteorological Department is responsible for the weather forecast because it established a lots of ground-based observations. So you can see that there are lots of ground-based observation. And ISRO is also contributing a lot for the AWS. They have installed lots of AWS over the continent. And similarly, there are lots of surface observations, right? And the radar network is also there. Then agromet observations is also there. And lots of institutions are also working with the farmers which provide basically the accurate the soil moisture analysis and etc. for the farmers. Similarly, in the space when, as Prajwal highlighted, that the satellite works basically as a tool for the upper air and upper air measurements. So India having a continuous monitoring satellites from a long time. Similarly, as I highlighted that there is a limitation of the computational facility, and India is leading in this direction. India having 3 major supercomputing facilities, Param Siddhi, Pratyush at Indian Meteorological, Indian Institute of Tropical Meteorology, Pune, and etc. NCMWRF having a huge high power computational facilities. So these are some steps that in which India is basically leading. So one of the case study of the Amphan cyclone is here. So you can see that this is not the forecast output from certain Indian forecast model, but Indian weather forecast model. But this is a typical picture that how the model is basically forecasting the track of that cyclone Amphan, okay? And the accurate prediction of such catastrophic event basically helps in implementing the suitable precautionary measures and take the necessary actions. So I will finish it here. So thank you. So the next speaker is Akanksha. She will talk about what we can do for the climate change. So please.
Hello everyone, my name is Akanksha Rajput. Today I will talk about what you can do about the climate change. तो जैसा कि अभी आपने प्रीवियस स्पीकर से सुन ही लिया है कि साइंटिफिकली हम क्लाइमेट चेंज और एटमॉस्फेयर से रिलेटेड प्रॉब्लम्स को कैसे डील कर रहे हैं, इतना डिफरेंट टाइप ऑफ इंस्ट्रूमेंट्स का यूज करते हुए. तो यहाँ पर मैं मेनली इस बात पर फोकस करूँगी कि हम एज एन इंडिविजुअल किस तरीके से अपनी डेली लाइफ एक्टिविटीज़ के थ्रू इन डिफरेंट टाइप ऑफ प्रॉब्लम्स को सप्रेस करने में हेल्प कर सकते हैं. तो सबसे पहले व्हाट इज़ क्लाइमेट चेंज. तो साइंटिफिकली अगर हम देखें तो क्लाइमेट चेंज is basically the statistically significant change in climate for an extended period of time. तो climate change एक ऐसा मेजर इशू है जिसके थ्रू, जैसा कि हम इस इमेज में देख सकते हैं कि ये एक ग्रीन एनवायरनमेंट को किस तरीके से एक ड्रॉट लाइक सिचुएशन में भी कन्वर्ट कर सकता है. तो मेन बेसिक जो कॉज है क्लाइमेट चेंज के वो है, जैसे ग्रीन हाउस मेन कॉज है कि ग्रीन हाउस गैस एमिशंस जो हो रहे हैं बाई नेचुरल एंड मैन मेड एक्टिविटीज़, जिसके थ्रू अर्थ का टेम्परेचर राइज हो रहा है. तो ग्लोबली अर्थ का एवरेज जो ग्लोबल टेम्परेचर है वो 1.2 डिग्री सेल्सियस इंक्रीज हुआ है. तो हमें सुनने में लग रहा है कि जस्ट 1.2 डिग्री साउंड सो स्मॉल, तो इससे क्या इफेक्ट पड़ेगा. तो इसको हम ऐसे रिलेट कर सकते हैं जैसा कि अगर हमारी बॉडी का टेम्परेचर 1 या 2 डिग्री बढ़ता है तो हमें फीवर या बहुत सी इंटरनल प्रॉब्लम्स स्टार्ट हो जाती हैं, हम अच्छा फील नहीं करते. तो उसी तरीके से हम अपनी अर्थ को भी अपनी एज एन बॉडी ट्रीट करें, तो यहाँ पर भी उसी तरीके से डिफरेंट प्रॉब्लम्स हम फेस करते हैं. और जो कि और ये इफेक्ट हमें जैसे डिफरेंट टाइप्स ऑफ एक्सट्रीम वेदर इवेंट्स के फॉर्म में देखने को मिलते हैं, जैसे कि सीजन्स चेंज हो रहे हैं, इंटेंस रेन स्टॉर्म्स के थ्रू फ्लड्स फेस कर रहे हैं, डिफरेंट सी लेवल्स राइज हो रहा है, ग्लेशियर्स मेल्ट हो रहे हैं, एंड देयर आर मैनी मोर प्रॉब्लम्स वी आर फेसिंग टुडे. तो हम एज एन इंडिविजुअल इन प्रॉब्लम्स को अपनी डेली लाइफ एक्टिविटीज़ के थ्रू किस तरीके से सप्रेस कर सकते हैं, उसके लिए मैंने यहाँ पर कुछ 10 क्वेश्चंस लिए हैं जिनके थ्रू हम प्रॉब्लम्स को समझने की कोशिश करेंगे और सॉल्यूशंस को फाइंड आउट करने की कोशिश करेंगे. तो और मैं चाहती हूँ कि इन क्वेश्चंस के आंसर्स चैट बॉक्स में आप लोग दे सकते हैं. तो लेट्स स्टार्ट फर्स्ट. So the first question is, which 5-year period was the warmest on record? And the options are 2001 to 2005, 2006 to 2010, 2011 to 2015, 2016 to 2020. अगर आपने प्रीवियस लेक्चर्स सही से सुने होंगे तो आई थिंक आप इसका आंसर सही से दे सकते हैं. So if anyone can guess. Hello.
There is okay. One suggestion. It says option 4.
Okay. Yes, it is the right option. 2016 to 2020 is the most warmest period of the period on record. So this is the right answer. So from this point, we can conclude that we are not in a normal situation. So we are already heading towards the catastrophic temperature rise of 3 to 5 degrees Celsius in this century. So we have to take this in account. And the next question is, globally, which of the following economic sectors emits the largest percentage of greenhouse gas emissions? And the options are transportation, Second is buildings. Number third is industry, and fourth is electricity and heat production. So anyone can guess?
The right answer is the option 4, electricity and heat production.
Yes, it is the right answer. So electricity and heat production globally contribute 25% of the greenhouse gas emission, and it is followed by the agriculture, forestry, and other land use, which is the 24%. So from this question we conclude that जैसे कि हमने देखा है कि हम ऑलमोस्ट अपनी डेली लाइफ में बहुत सारे अप्लायंसेस यूज करते हैं जो इलेक्ट्रिसिटी एंड हीट के कॉन्सेप्ट पे काम करते हैं, तो हम ज़्यादा से ज़्यादा वेस्टेज को मिनिमाइज करके इसके रिडक्शन में कंट्रीब्यूट कर सकते हैं. नेक्स्ट क्वेश्चन इज, which of the following is not a reason why biodiversity is important? And the options are, first is biodiversity loss would decrease water quality. Second is there are too many animal species on the world. Third is many species act as the pest control. Fourth one is biodiversity ensure food security by supplying a wide variety of plant and animal species for nutrients. Biodiversity loss decrease available nutrition. So please read the question correctly. Which of the following is not a reason why biodiversity is important? So which one should be the answer?
Is it second?
Yes, it is right. So biodiversity basically promotes healthier, maintained ecosystems, and it provides services such as protected water resources and also recovery from disasters. And the genetic variety of crops, livestock, and marine organisms also provide healthy and nutrient-rich diets. And variety of diverse species are also able to take care of pests in ecosystems. So we have to take care of this also. And the next question is, how many trees does it take to provide a day's supply of oxygen for 4 people? And your options are 1, 10, 50, 100. Anyone?
Option number is 1, right?
Yes, it is correct. So, one large can tree is able to supply a day's supply of oxygen for 4 people. Even trees are also able to absorb up to 48 pounds of carbon dioxide a year. So, it emphasizes that we have to do more tree plantations so that we can overcome to the large emission of carbon dioxide. Next question is, what can you do to fight deforestation? And the options are, first, leave forests standing and plant more trees. Reduce your use of products made from wood fiber, including paper and cardboard. Third is, demand forest products from sustainable sources and deforestation-free supply chains, or all of the above.
Fourth, all of the above.
Yes, absolutely right. So these are some steps to fight deforestation. So can because the loss of trees and other vegetation can cause soil erosion, flooding, desertification, which increase greenhouse gas and of course the climate change. And these also create problems for indigenous people. And apart from these solutions, we also suggest that recycling forest products we can also use in our daily life. And the next question is, what happens to plastic waste when left in the environment? And these are the options. First is, it is a biodegradable material, so it eventually disintegrates. Second is, it never fully goes away, it just breaks into little pieces. Third is, there is no such thing as plastic waste, all plastic is recycled. Anyone?
Okay, there is an answer in chat. It says second.
Yes, it is absolutely correct. And so basically, from the study by UN Plastic Collective, it shows that India generates almost 9.46 million tons of plastic annually, and out of which only 40%, remains uncollected, and most of which is single used. So how so the next question is based on how we tackle this problem, this single plastic use. So uh, so on average, how long is a plastic bag used by a person before being thrown away? And the options are: first is 12 minutes, second 1 hour, third 1 day, fourth is 1 week. Anyone can guess?
Option 1, 12 minutes.
Yes. So on an average, according to 5-year institute that focuses on reducing plastic pollution, they found that 12 minutes is the average working life of a plastic bag before it is thrown away. So globally, 1 million plastic bags are used per minute, and only 1% of them are recycled. Most of them make their way to the ocean, where they can take up to 20 years to decompose. So the this so the next question is wasting less food is a way to reduce the greenhouse gas emission? It is true or false? I think obviously it will
Option 1 should be right.
Yes, it is true. So, uh, so uh, just more. So here, more than 1/3 of the food produced globally never makes it to the table, as this food spoils in transit, and consumers also throw it out. And globally, food loss and waste account for 8.2% of the total human-made greenhouse gas emission. So this is also the one major cause of greenhouse gas emission. So here from we suggest that we uh, reduce the wastage of food as much as possible. So next question is, which are the alternatives to single-use plastic products? And the options are: carry reusable shopping bags, carry a stainless steel bottle or mug for coffee and drinks at all times while outside, request for zero plastic packaging when ordering online, or all of the above.
There is answer in chat. It says all of the above.
Okay, yes, it is right. And apart from these solutions, there are also some other solutions, like we can choose paper over plastic whenever possible. We can buy the product in bulk to reduce packaging waste, and also use glass containers for food storage. And if you search in internet, you you can find hundreds of solutions to reduce the single-use plastic waste. So I request to follow all these steps in our daily life. And the last question is, what can you do to help fight climate change? So we can also engage ourselves in the science behind the climate change, and we can change our lifestyle according to environment friendly. We can vote for those political candidates who will advocate for climate related legislation and policy improvements, and all of the above. So the answer should be
All of the above.
yes. The answer is 4. So these are some steps. So we can, by following all these steps, we can help to all government policies and scientists also to fight climate change. And so I would also suggest that we can also add our voice to issues surrounding the climate change and take personal actions to reduce your impact on the planet. So now you have to decide which type of future we want. Is it this? In these pictures, what we can infer. So if we do not control all uh, these problems, so maybe the future is like future is like for our coming generation. So the decision is yours. How do you want your future? And thank you.
Thank you, Akansha.
Yes, sir. Who?
So now we are open for questions. If there are any questions on any of the 4 talks.
So all the participants, I mean, if they are interested in a discussion out here, or if they have any questions,
And
or if not, then
yeah.
yes, you can always
Additionally,
email us.
I just would like to say there is comments from Professor Shyamlal, and it says that a recent study shows that salt made from seawater has a small plastic particle or nano-sized plastic particles.
Yes.
So that is,
Right.
I think, again, some kind of warning to us for basically proper disposal of the plastics or those things. I think this is very useful information. And
Right. Even in fact in fishes.
Right. Yes.
yeah.
Okay, so maybe if not, then we can
I would like to just add maybe one point of about recycling. So it is believed that, okay, you can continuously keep on doing recycling, or at least many times you can recycle these plastics. So, but I just want to mention this because I came across this on a very reliable show or documentary kind of show where these issues are dealt with. And it was said that most of the plastics is actually, it's possible to recycle it only once. So even if it is a recyclable plastics and not a single use plastic, at the most it will be recycled only once. So you can say it is going to be used just twice. And even it's not like that all the recyclable plastic gets recycled. I mean, a lot of it is just discarded, and only a very, very small fraction, less than few percent, gets recycled.
I think
I would like to add something. Actually, I mean, first of all, I would like to congratulate or thank all these students. They have done really good, presentations, and of course, very informative, very useful presentation. So as far as this plastic pollution is concerned, like Manishji also told that it has come through oceans now. Moreover, adding to that, it is reaching up to the Himalayan, higher Himalayan altitudes over glaciers. We call it microplastic, presence of microplastic in the glaciers. And above and all, what we can say, I mean, because this is an unavoidable or inevitable problem, we can say, because plastic is a byproduct of petroleum, processing, whatever natural gas or say petroleum products, this oil we are extracting from the oceans or anywhere. So it is a byproduct of that. So it is unavoidable at source itself. So if we and moreover, it is very difficult to store somewhere so that we don't create plastic. So then again, question comes to that we have to go for the natural sort of recycle sources or green sources. That is, I mean, again, big challenge for the world or the globe as a whole. So, but then thank you all the students for doing this such a nice program. That's it from my side.
Just another approach also very very famous these days, that you can utilize plastic to make roads. So I know we cannot we cannot just get away with the plastic that we have already created, but we need to make use of that in some innovative ways, so that it is not lingering around and polluting the atmosphere or the environment in general.
Yes, good point. And thank you, Narenji, for the very important.
And thank you to Virendra, who has been, I mean, of course, very leading this program and organizing for last 3 days.
Thank you.
Yeah. Thank you so much.
Maybe I think you should also thank Virendra for for continuing, also for continuing for the last 3 days and also for tomorrow.
Thank you, sir.
Activity.
Hello, Premji.
There is also another question in chat.
Yeah.
Asking, how do you differentiate the sources of pollution with respect to Himalayan region and non-Himalayan region? So the quick answer is that we use some Lagrangian models, and by using which, and by combining them with the observed concentration and some source tracers, we can actually differentiate between the pollutants which are local to the Himalayan region and which are actually coming from the long range transport.
I would just like to add one more point, Chakravarti.
Yes.
That the pollution that we are usually having in the Himalayan region, or say the sites, pristine sites like Himalayan region, is basically of natural origin, we can say, whether it is long range transport or say biomass burning is a kind of, it doesn't produce NOxes or anything, I mean, which is the resulting from the fossil fuel combustion. Yeah. But basically CO2, CO, and major like black carbon kind of things. So that is more or less, absorbed or, managed by the nature itself. Say, for example, forest, trees, plants, or other things. So the origin can be, more natural, whatever we see in the Himalayan region, and rather than what we see in the Indo-Gangetic Plain or industrial regions where you have a lot of very, deadly chemicals or say very harmful chemicals emitted, emanated, or propagated into the different sites transported from one to the other side. So that is the basic difference what we can differentiate in Himalayan region or say in the plains region or non-Himalayan region. Of course, there may be other various techniques like model what Priyanka just now mentioned. But then, whatever, if you are receiving something here which are not created here or produced here, so definitely coming from somewhere else. But naturally, we are away from the artificial pollution, we can say.
Hello.
Right.
Hello.
Yes.
Brenji, I can also add a point with Naren sir. I agree with the Naren sir that the natural in Himalayan region, we observe that the major source of pollutants are the natural, and but the anthropogenic region is from the other sides. For example, from the IGP region. That's why the ARIES is situated here to know or to observe the inflow from the IGP or other regions to that Himalayan region, because this site is very very nice for the such kind of the observation to measure how much anthropogenic pollutants came from the IGP and other the long range or local. So I think this is also right.
Right. Thank you for that comment. Any more questions or comments? Okay, we don't see any in the chat. So thank you, Mahinder, Priyanka, Prajwal, Jaideep, and Akansha. These are all our research scholars who are doing their PhD research work in our atmospheric division. So I think we can close here then.
Can I say?
Yeah, yes, sir. Please.
Okay.
Yes.
Of course, I attended the full, and these people have really prepared very well. Presentation has been good, and question answer also. But there was not much questions from other people, so that should have been little more interaction, because these people have prepared so much and expert in this field. Other people would have taken advantage of their expertise. That we missed. No problem.
Correct.
But anyway, these I congratulate all 4, 5 for this. Even their presentation, talking, good. So good. Keep it up and be expert in this field. Bye. Thank you.
Thank you, sir. Okay, so you can stop the sharing now, and we will close it.